Welcome to another podcast from MC Rapology. Now, first and foremost, I'm going to tell you this. Subscribe to the channel, give me podcast a like, give me a reason to keep going with these podcasts. Now, the topic we're talking about tonight is 10 methods that are either in the works, used frequently or infrequently, or in the realms of possibilities when it comes to intersolar propulsion. Now, there's 10 methods that are defined that we know of that NASA either has in the works, has prototypes, or at some point has used or has theorized using. Now, this is going to be dedicated to those 10 propulsion methods. Now, I'm going to start with Mars. Now, Mars is 63 million kilometers from Earth, and it takes a long time to travel there. Now, the first method on the list to use if we wanted to get to Mars would be chemical rockets. Now, chemical rockets, they have, as it stands, a 60% efficiency. Now, as a lot of people may know, the further you want to travel with a chemical rocket, the more fuel you need and the more weight. So, not the best way to really use something if we want to talk about chemical propulsion. If we do use chemical propulsion, it would take some time to get to the edge of the solar system. It would take 40 years using a chemical rocket. And you just wouldn't be able to get that much fuel on something to make that practical. And that's a chemical rocket, can travel at a maximum speed of 260,000 kilometers an hour, but it is not the preferential choice here. So, chemical rockets were the standard 40 years ago, but now we are moving away from that because, if we want to travel the solar system, if we want to travel to Mars, we cannot be talking chemical rockets. So this is not the focus anymore of really anything because they're so expensive to use chemical rockets. They're not efficient. They're bulky, primitive technology that's of a bygone era. So slowly, chemical rockets are phasing out of the equation. Now, number 2 on the list is electrothermal propulsion. Now, electrothermal propulsion has its benefits, but it's also got its downside. Now, it's got a theoretical speed of 321,000 kilometers an hour. It's not too bad. I mean, basically with electrothermal, you're expelling propellants at high speeds, but there's a limit. The limit is the electrical power used. That you need, that it's not very practical because you need a lot of electrical power to use an electrothermal kind of propulsion system, and so you need a very high energy source, something that can hold a lot of electrical charge. So, the problem is you can't really get a craft to leave Earth's atmosphere with electrothermal. With traveling space, yes, you can use electrothermal, but, it can achieve high speeds over a long period of time, which is another, benefit. But the trouble is the amount of energy storage you need is significant with this technology. Satellites use electrothermal all the time, and it's good for station keeping. I suppose it's a benefit. If you wanted to use this, you would need some type of nuclear power system on board to take care of your energy needs, but it is in the realm of possibilities of being used on interstellar craft if you want to travel on an intersolar course. So an intersolar course is traveling within our solar system. It wouldn't be a bad idea, but there is more preferable methods, and we're going to look at that now as we move on. Ion drives, the third one. That's probably the biggest and most important one. They can't be used to launch vehicles through the atmosphere as any ionizing gas outside the engine, it just would render it useless. It just wouldn't work because the whole ion drive thing is using ions as an accelerant. So, they accelerate a stream of electrical charged ions at high speeds to achieve thrust. Now, it has an incredible theoretical speed, and it's why it's one of the most promising propulsion systems that are actually in the works by NASA, and they have been working on this a long time, and it is probably, in my opinion, the technology that is going to make intersolar travel very possible, and travel to Mars very possible, and in the near future, make exploration of our solar system commercially viable and accessible to a lot of people. And corporations and multinationals will embrace this ion drive technology. I'm sure, Elon Musk will embrace ion drive technology in the future because its theoretical top speeds can reach 2.1 million kilometers an hour. Hence why NASA is so keen on the ion drive. And they're working on an ion drive called the X3. It's also known as the Hall thruster. And it would only take us 5 years using this technology to get to the outer rim of the solar system. And that's not bloody bad. 5 years to travel to the outer rim. Remember, with chemical rockets, it would take 40 years. With ion drives, as they stand, 5 years. But as they improve prototype models, that the time reduction, the theoretical time reduction, the calculations will be much less. But ion drive looks very promising, and it's probably one of the big ones that we need to pay attention to. Now, another one is using solar sails. So that's using charged particles from the sun as a way to propel a vehicle away from the sun. So charged particles hit the solar sails, and also that electrical energy is used to power the craft. It has a theoretical speed of 240 kilometers an hour. I remember when there was a Star Trek Deep Space Nine episode that had I think if I remember correctly, it was a Bajoran ship that used solar sails, and it was one of their very first prototype ships. It's something that popped to mind just then when I was thinking of solar sails. I don't know how many people are into Star Trek, but now number 5 on the list is plasma propulsion engines. They are like an ion drive but on steroids, and they are very impressive. Now, a plasma propulsion engine, instead of using non-reactive fuels, it uses magnetic currents to accelerate ions into a plasma to generate thrust, and is very, very powerful, and is probably something that could possibly be used if we're talking about leaving our solar system and traveling to another nearby solar system. Because there is something in the works. It is called VASMIR, Variable Specific Impulse Magnetoplasma Rocket. Now, that's what that acronym stands for, VASMIR. Now, it has a top theoretical speed at the moment of 180,000 kilometers an hour, but a 200 megawatt engine could reach Mars in 40 days, taking about 12 days for the propulsion system to launch a vehicle to its top speed, running at 60% efficiency. So, if it was running at 100% efficiency, just think that's, an incredible propulsion system. And probably plasma propulsion, eventually they will more than likely design a plasma propulsion system that can reach incredible speeds. So it is very, very promising. Now, next on the list is a thermal fission engine. And it has a theoretical top speed of 600,000 kilometers an hour. A fission reaction would be used to heat propellant to extremely high temperatures to generate thrust. Fission would be achieved using lasers. The trouble is, it's like, if you're talking about using fission reaction, there's a space treaty that bans, any type of fission or fusion reaction in space, and it's called the Outer Space Treaty. So it's unfortunate, but this is something that exists. Now, thermal fission engines could be used in the future if they discover a way to design these propulsion systems as safe. And, there's some international law changes that enable nuclear designs of propulsion systems used in space. Number 7 on the list is continuous fusion engine. Now, a continuous fusion engine basically does what the sun does all the time. It continuously has a fusion reaction happening. It cannot be achieved at the moment, but there is a lot of work going in to continue to actually have a demonstration of continuous fusion. Because if you have continuous fusion, you basically replicate what the sun is doing. And it would be incredible because then we could harness the energy from it, and it would be an ultimate energy source. You could power the whole ship using continuous fusion and use it as a propulsion system. And it would be ideal for long journeys because, you have an incredible power source. The next best thing down from continuous fusion is to have pulsed fusion, so have fusion at intervals, not continuously. And that's a little different, so it's basically a controlled detonation of a miniature fusion bomb. Maybe every 5 minutes a fusion bomb goes off. And that would work by dropping, pellets, I guess, of 2 hydrogen isotopes surrounded by rings of lithium in a combustion chamber or something like that. So pulsed fusion, number 8 on the list. Yeah, it's possible to use. Pulsed fusion is more realistic than continuous fusion, but they're 2 things that are, theoretically, proposed by NASA. But whether we'll ever see a working model of this, they try and demonstrate, that it's possible to have continuous fusion. It hasn't been achieved yet, so hopefully that will become reality. Now, number 9 on the list is a nano spacecraft. Now, this is the most interesting one because if you wanted to cheaply launch to another solar system, all you have to do is create a miniaturized nano sensor or device that has multiple sensors on it that is nano size, and you could launch that at nearly the speed of light using lasers, and you could travel to nearby solar systems in 5-6 years, launching at a nano device at nearly the speed of light using lasers. Now, it's an incredible concept, and it's one that is being heavily explored by NASA because it has a lot of promise. And, you would only be able to use a nano spacecraft, to basically, use as a sensor to, determine the composition of an atmosphere of a planet or the workings of a solar system. It would work a bit like a tiny particle accelerator, I guess you could call it. Like this nano spacecraft would be accelerated like a particle in a particle accelerator at very high velocities, basically using electric fields between 2 charged plates. And each chip that you sent off could contain millions of tiny electrical launches. It would be an incredible feat if we could, do something like that. And in the near future, I think that will happen. I think that, nano spacecraft will be a big possibility. And last on the list is something that is not so possible. It's been envisioned in Star Trek. I guess you all know what I'm talking about, yes. Antimatter reactors. It has been proven that antiparticles can be created in a controlled environment, and they don't last very long. There is no way to store antimatter that we know of that we can do successfully. There is theories on how to store antimatter using magnetic fields and things like that, but it's been really hard to demonstrate actually being able to harness antimatter. It's a long way off, maybe in 1,000 years, yes. antimatter will creep into propulsion systems. Until then, I don't think it's in the realm of possibilities anytime soon. And when I say soon, I mean in the next couple of 100 years. So we've looked at our list, we've explored the list. To give you a recap, we covered chemical rockets, then electrothermal propulsion systems. We covered ion drives. We also covered solar sails. Number 5 was plasma propulsion engines. Number 6 was thermal fission engines. Number 7 was continuous fusion engines. Number 8 was the next one down from that, which was pulsed fusion. Number 9 was the nanoparticle spacecraft. And number 10, yes, every trackie's favourite, the antimatter drive. So, what do you all think? Let me know. It would be good if we could travel to the very easily through our solar system. Interstellar travel is something we need to achieve in the next 100 years. Our survival as a species depends on our ability to be able to travel from planet to planet. And that's what it's about. So we must go forward into the big, wide universe and explore. Let me know what you think. Subscribe to this podcast. I'm fascinated by this. I love the idea of new technology. I want to see us be able to travel in the realm of our solar system in at least my lifetime. I don't want to be disappointed. I don't think NASA's going to disappoint me because they're hard working on the ion drive. It's something that I think will become a possibility, and if you want to look into it, look at the X3 because that is the most promising thing. NASA have a prototype. They will keep working on that, refining the technology, making it more stable, more functional, more efficient, more capable. There's a lot of mathematics that go into design. There's a lot of physics, a lot of chemistry. They all meet up, and a lot of smart people come together, and they build some incredible things. So, we've got to look. If you want to have a look at the Xenon thruster, the next project NASA has, go for it. It's something that's worth looking at. Do your own research. Let me know what you think. Do you love space like I do? Do you love technology like I do? I think you do, because you wouldn't have listened to this podcast this long if you didn't like science and tech and space. So, anyway, I'm MC Rapology, not just a guru of music, a guru of science, technology, and the world all around me. Anyway, peace.